So continuing with our biochemistry unit, we're going to move on to chemical reactions. A chemical reaction is when one substance or set of substances changes or transforms into new or different substances. So again, the key phrase here is that we're creating new or transforming it into different substances. So if you start with one particular material, if at the end of this change it's still that same material, then it is not a chemical reaction. So for example, if I take paper and I end up ripping the paper, it has changed, yes, but this is not a chemical reaction or a chemical change, it's simply a physical change, because in the beginning I had paper, in the end I still have paper. Same thing with if I take ice and I let that ice melt. That is not a chemical reaction, because in the beginning we had water, at the end we still have water, it's simply changing state. So in order for a certain change to be considered a chemical reaction, we have to be ending with new or different substances than what we had in the beginning. When we're talking about a chemical reaction or representing a chemical reaction, we always write our initial substances over here on the left. These are the substances that are going to react. And then our final substances we write over here on the right, and these are our final products, or what has been formed because of the chemical reaction. We also separate these two by an arrow, and this arrow just kind of represents a transformation. So the arrow pointing in the direction of the product means that the chemical reaction is running in this direction. We're going from our reactants to our products. There are certain types of chemical reactions where we're actually going from a typical product back to a reactant, or we can even have it going in both directions. So as we're forming product, we're also changing our product back into reactant. So most typically you'll end up seeing our chemical reaction moving in this direction, but being aware of those other types of chemical reactions is good as well. So let's talk about energy within a chemical reaction. What I can do is I can plot the energy of my substances over time. So I have time on the x-axis, and I have energy on the y-axis. So at one initial point, the energy of my reactants, I'm going to plot here. What we end up seeing with a chemical reaction is that we're going to have one of two things happen. But we're always going to start at the energy of our reactants, and as time goes on, those reactants are going to end up gaining energy to a certain point, and then we're going to go through a chemical reaction. So our graph could look like this, or it could look like this. So looking at both of these graphs, the one thing that they share in common is we're starting at the energy of our reactants, and then our reactants are going to gain energy in the beginning, right? So it shoots up to this point in both of these graphs. So that energy that our reactants are gaining is called my activation energy. So if I plot it off to the side here, the amount of energy that it takes to go from my reactants up to this top point, that is my activation energy. And same thing over here. So again, it's called activation energy because it's the amount of energy that is required for our reactants to absorb in order to activate that chemical reaction or get that chemical reaction started. Once we hit this point, once we reach that activation energy, then our reactants are going to be reacting to form our products, and our energy is going to drop back down to the level of our products. So in our first graph, we see that the energy level of our products is lower than the energy level of our reactants. So when our energy level of our products is lower than the energy level of our reactants, This is an energy releasing reaction. And again, this occurs when our products are lower than our reactants on this energy graph. Typically, we're talking about thermal energy or heat, and so when a reaction is an energy releasing reaction, it's typically what we call an exothermic reaction, meaning it's giving off heat. In our second graph, what we see is that the energy level of our products is higher than the energy level of our reactants. So this is an energy absorbing reaction. Okay, and where we had an exothermic reaction here, in this case what we're doing is we have to absorb energy or absorb heat. So when we're absorbing heat, it's going to be called endothermic. Just think exo, heat is exiting, endo, heat is coming in. So energy releasing is exothermic, energy absorbing is endothermic. Again, energy absorbing is when our products, energy of our products is greater than the energy of our reactants. So going back to this activation energy, for any chemical reaction to occur, we've got to first absorb this amount of energy in order to get that chemical reaction kick-started. So we have talked about proteins as one of our macromolecules, and one of the functions of proteins is as an enzyme. And so what an enzyme does is an enzyme acts to decrease this activation energy, make it less, so our chemical reaction can get started faster. And so we'll finish up the discussion of this on Monday, and we're going to go into depth on our enzymes and how it is that they end up decreasing that activation energy.